questions from homeworks.
Unrelated, but can I go to the bathroom? Sure.
Yes, Chanel?
Number 19.
From the problem set?
Yes.
Sure. Judging by what I saw looking at your homeworks when I went through and graded things, there should be a fair amount of questions here from things because that was completed to various degrees of success. All right. First thing I'm going to do, I got to get rid of the squared on the cosine, so we'll square root both sides. When I square root both sides, I need a plus or minus. The square root of 1 is just 1. The square root of 2, I'll write as the square root of 2. So I rationalize this to be root 2 over 2. So I'm looking for where x is equal to the cosine inverse of plus or minus root 2 over 2. So if I go to the unit circle and look for the x coordinate, where it's root 2 over 2 or negative root 2 over 2, that's pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. That's my answer for part A. Okay. For part B, I can go and just tack a plus 2 pi k onto each of these. Oops, 2 pi k. That's fine, but you could make it simpler, yeah. So if you notice, between these two is a half a pi. Between those two is a half a pi. Between those two is a half a pi. So every half a pi, I'm going to run into a solution. So I could simplify this down to that, where k is an integer again.
Oh, that's not, I think that's what I did. I did, like, I believe I did x equal pi over 4 plus pi n, and then 3 pi over 4 plus pi n.
That's okay.
Well, that works too.
It gives you the same set of solutions. It's fine.
Okay.
Yeah, it doesn't have to be as compacted down as possible.
Okay.
I just, when I wrote the answer key, because it's like a pain in the butt to type these, to like typeset like these things, I just tried to do it as compactly as possible because it's way simpler for me. Let's see, part C was, I think, that interval, right?
Yes.
Okay. So all of my answers for part A fall inside that interval, right? All of those are between negative 2 pi and positive 2 pi. Now, to get my, in fact, those are the only answers between 0 and 2 pi. So really what I need is then the stuff between negative 2 pi and 0. Right? So how am I going to get those? Well, I can just subtract 2 pi from each of my other answers. So like pi over 4 minus 2 pi, negative 7 pi over 4. 3 pi over 4 minus 2 pi is negative 5 pi over 4. 5 pi over 4 minus 2 pi is negative 3 pi over 4. 7 pi over 4 minus 2 pi is negative pi over 4. So I think on the answer key, I wrote those all as plus or minuses, which again, doesn't have to be. You can write them this way. I just wrote it in the compactest form.
What I actually did is I took the equation, like x equals 3 pi over 4 plus pi n, and then like plug in
values for k. Yeah, that's the exact same thing we're doing. Yep.
Oh.
I just did it without,
Yes.
I did these, right? I used -1 for k
Yeah.
on each of those
Yeah.
because Well, it was just meaning subtracting from the answers I had already written down, which felt easier than like, but yeah, you're doing the exact same thing. It's the exact same thing. Right idea, 100%. And then the last one, I think that's our interval, right?
Yes.
Okay. So from the list, I already have most of the answers, right? Everything from negative pi to 2 pi, I have up here already. So I'll just write those down. So I have negative 3 pi over 4, negative pi over 4, and then positive pi over 4, positive 3 pi over 4, positive 5 pi over 4, positive 7 pi over 4. That's all the stuff from negative pi to 2 pi. I didn't include those two guys because they're too small, but everything else is okay. And then I just need to worry about the stuff from 2 pi to 4 pi. How am I going to get that stuff? I'm just going to take those 4 and add 2 pi to them.
Okay.
Or you could, take these and plug in k to be 1, or I'm sorry, 2. Or no, 1, excuse me, k to be 1. Or you could do, if you had 2 sets of them, you're plugging in more values of k, but like that's fine. Either, any of that is fine. It's all doing the same thing. So I don't know, it's 9 pi over 4, and then 11 pi over 4, and then 13 pi over 4, and then 15 pi over 4, and that would be it.
Okay.
Does that feel okay?
Yes, thank you.
Sure. Sounds like you are doing a good job already. Allie.
Can you do number 30?
Sure. Let's take a look at 30. Okay. 3 tan squared minus 1. Okay. So first thing I'm going to do is get the tan squared by itself. So I'm going to add 1 to both sides. And then divide by 3. And then we'll square root both sides. When I do that, I get a plus or minus. And then we'll do the tan inverse of both sides. But I have a small problem here because there's not a place on my unit circle, if I go and I look, that has the y coordinate square root 3 and the x coordinate 1. But I do have the y coordinate square root of 3 over 2 and the x coordinate 1 over 2. That is something I do have. And I know that the halves would just, like, the denominators just kind of cancel out because they're the same on the top and bottom. So that works. So that's what I'm going to go search for in my unit circle. Let's see, y over x. So that's at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. I think, let me just grab the unit circle real quick and double check that, I guess. I don't want to screw that up. X is a half, a half, a half, and a half. Okay, good. There. Okay, so that's my answer for part A. Now, in part B, I could write all of these plus 2 pi, or I could notice that, like, hey, those are pi apart, and those guys are pi apart, and combine those answers, which is what I did. Now, do you have to do that? No, you don't. But that's the way I wrote it on the answer key. Would it be fine to write all 4 of them plus 2 pi k? Yes, yes, 100%. Still doing okay, Allie?
Yeah.
Okay. Part C, that was negative 2 pi to 2 pi. Again, all of my answers for part A are good. Morgan?
Why are we, like, why for some of them you had 2 pi k and then the other ones are just pi k?
So
I didn't hear.
so
Sorry.
I could write this, all 4 of these,
Yeah.
plus 2 pi k. That's correct.
Okay.
When I wrote the answer key, I'm going to write it in the compactest way possible. I noticed that these two are pi apart.
Yeah.
So I can just combine those solutions and write one that's just pi apart instead of 2 of them where they're 2 pi apart.
Oh, okay.
That's all I did.
Sorry, I wasn't paying attention. I didn't get that.
That's okay. And it's okay to just write them all as 2 pi ones.
Okay.
That's okay.
Okay.
So I have those parts already. I'm just going to write down A instead of recopying them. Is that okay, Ellie? I now need to worry about these parts. So to get those, all I'm going to do is subtract 2 pi from each of these, right? And that'll give me something coterminal to that that's negative. So that's going to give me negative 5 pi over 3, and then negative 4 pi over 3, and then negative 2 pi over 3, and then negative 1 pi over 3. And if I subtract again, they're all going to be too small, right? Okay. D is, what is that, negative pi to 4 pi. So I wouldn't want those two because they're too small. Those are less than negative pi. But every other answer from C is good. Let me rewrite them. So that's going to give me all the stuff from like negative pi to 2 pi. I then just have to worry about the stuff from 2 pi to 4 pi. How am I going to get that stuff? I'm just going to take these answers and add 2 pi to them. And again, 2 pi is 6 over 3. So it's, what do I got here? I have 7 pi over 6. And then I have 8 pi over 6. I'm sorry, 8 pi over 3. 7 pi over 3, 8 pi over 3. 10 pi over 3. And 11 pi over 3. If I add again, they're all too big.
So, just like out of curiosity, like a general pattern for C, is that always going to be like the opposite or like the same but negative? If that is, does that make sense? Or is that just like
Yeah. Oh, no, not the same, but the negative. It's going to be the answers from A minus 2 pi.
yeah? So it just ends up
No. It was because this was a plus or minus situation that you ended up with that. If it wasn't plus or minus, then the same thing would not hold.
okay.
What you said would not hold. It was specific to this one. And I think that it was a tangent. If it was a sine one, I think that would get all googled up.
Okay. Thank you.
You're welcome. Chanel.
You need number 15.
15. Sure. Oh, this one, just the answer is wrong.
Oh, for 15.
On the key, yeah. Somebody else.
That was funny.
Tessa, did you ask me about this earlier? I talked to somebody about this, right? Yeah, the answer for 15 is for which part was it? Was it part C? C was wrong. Yeah.
Can you do 25 instead then?
Okay. Sure. Somebody asked me about something like 29 though at some point because almost nobody did those ones. So you were doing 19? Or 26 or 38 or a bunch of them like that. You said 25. I'm sorry. Okay. 2 tan squared x equals 6. Okay. So I divide both sides by 2 to start. And then we'll square root both sides. and I'm done.
It's the same thing.
Oh, look.
That's true. Because on the answer key.
Then it must have been a mistake.
Okay.
Can I point out to you guys that I don't know that, like, it seems, like lots of people have asked about this, but these are all checkable. Like, if you think there's a mistake on the answer key, you can be like, oh, okay, so the problem was like 2 tan x squared equals 6. I can just plug in the answer from the answer key if it's supposed to be like, like pi over 3 was the answer. And I can see if that gives me 6 or not. And if it doesn't give me 6, I know it's wrong.
Yeah.
Yeah. I need to be in the right mode, though. I think that should have been an answer.
Yeah.
Right? But if the answer key said, like, oh, it should be pi over 6, it's like, well, no, I know it's not pi over 6. That was wrong. So it just would have been a mistake, So, like, please check. Like you learned how to check in like pre-algebra class, where it's like plug it back into the equation, make sure it works.
Yeah.
Same thing still applies here. Still, it's just a solving problem.
Okay, got it. Thank you.
Yeah, no problem. I don't mean to like cut you off there, but I wanted to like I don't want to spend a whole bunch of time doing a question where like the root of the question is, was there a mistake on the answer?
Yeah.
Which was what was going on, I think.
Okay, thank you.
You're welcome. Tessa. Well, these answers that we're getting, these intervals, those are radians, right? So the calculator, if you're checking, should be in radians. Yeah. Ellie. 38. Oh, yeah, that's a good one. This one's one that if you don't really understand what's going on, you really get thumped on. So sine squared x over 3 equals 3 cosine squared x over 3. God bless you. Here's the trick. So this looks kind of intractable, right? Because we have both sines and cosines in here. Here's the trick. Now, how many of you are going, Mr. Kulik, wait a tick. You're not supposed to be dividing by variables, right? What can happen if you divide by variables? Could be 0, right? So you might be losing solutions. Why is it okay in this case? What's that? It's tan squared. So I am taking into account that denominator being 0 because tangent is undefined places, so it's okay. I'm going to account for it when I do the solving. So now we'll, God bless you again, square root both sides. We'll do the tan inverse. We just did this above. What were those values? They were the denominator. Okay. So I have x over 3, or pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. However, on a problem like this, where there's a coefficient on my x, I need to do part B first. Hold on, guys. And again, you could compact some of these together if you wanted to. I'm just choosing not to for the clarity's sake here going forward. Oh, come on now. Okay. To get the x by itself, what do I have to do to both sides? Multiply by 3, right? Everybody agree? Here's the trick. That 3 distributes. So 3 times pi over 3 is just pi plus 6 pi k. And then I have 2 pi plus 6 pi k. And then we have 4 pi plus 6 pi k. And I have 5 pi plus 6 pi k. So this is my answer for B. Now to get my answer for A. A was, what was it, 0 to 2 pi, was it? It was like this, wasn't it? I don't remember. Was it a bracket on the 2 pi or a parenthesis on the 2 pi? Parenthesis. Okay. So the only one that's going to give me a solution is this piece, where k is equal to 0, right? Any other value for k in any of these other solutions is going to give me something either bigger than 2 pi or less than 0. So I just have one answer here, just pi. C was negative 2 pi to 2 pi with a bracket on each end, right? So if I look at that first solution, well, obviously pi still falls in there. If I look at this one, if k is 0, I get 2 pi, right? That fits in the interval. If I look at this solution, well, if k is 0, I'm too big. I'm at 4 pi. But if k is negative 1, I have 4 pi minus 6 pi. That's negative 2 pi. That one works. And if I look at the last one, oh boy, I can't write that. Use yellow again, I guess. If k is 0, I have 5 pi. That's too big. But if k is negative 1, 5 pi minus 6 pi is negative pi. That fits also. Now if I go negative pi to 4 pi, well, I have negative pi that fits. I have pi that fits. I have 2 pi that fits. But if I try to do any other one, I can get to 4 pi, but that's not included because it's a parenthesis. So that's it. It's just those 3. Any other values of k are going to give me something either too big or too small. That feel okay?
Better, yeah.
Better. Again, the key here on these ones where you have a coefficient on the x is you have to do the infinite solution first and then use that to generate the other pieces. Because you're going to either get too much or too little. Almost always. Or it's just geometrically it gets too confusing, I think, to try to hold on to like how much of a period, like how much the period is expanding or contracting. Mary.
Do I do 29?
Sure. 29. Oh yeah, okay. Same trick. Just a less complicated version of it. So again, sines and cosines together in the same problem. Divide to make it into a tangent. Now, the problem is that tangent is y over x. So I really want the only place on the unit circle where the y and x are the same. Oops, negative, sorry. So that's my answer for part A. Since there's no coefficient on x, I can solve part A straight away. Part B, all I have to do is slap a 5 pi, you dumb, that's 7 pi. Slap a 2 pi k on these, or I can observe that these are pi apart and just put a pi k at the end of it, one of them. Either is fine. Part C, I'm going to have my answers from part A. And also if I subtract 2 pi from them, so that's going to give me negative 5 pi over 4, and then that one would give me negative pi over 4. And then for part D is going from negative pi to 4 pi. So all of my answers from the part C, except for the negative 5 pi over 4, fit in that interval. And then I have the stuff that's between 0 or between 2 pi and 4 pi. So I'll just take these two and add 2 pi to them. And that'll be it. Yeah. Oh, excuse me, guys. Do you want to talk about the test format here for a minute?
Sure.
Take a little break in case. So if I look at the review packet, I have the test format already set up. Keep in mind, no calculator allowed. Oh no, it'll be fine, guys. You'll see why in a second. There's 11 total questions. You only have to answer 8. Okay? The first 3 questions are required. So these required questions, you have no choice. You must do these 3, are going to be of these following 4 types. So find the trig function using a reference triangle. That was like from the problem set, like numbers 1. Or I'm sorry, like 3 through 6, right?
So you can use reference triangles, you don't have to use the identities?
That's the direction says using a reference triangle.
Okay.
The next one says use identities to find the value of something. That's the same problem, just with an identity rather than a reference triangle. So it's the same question, just how you're doing it. Solve trig identities for specific angles on the unit circle. That's 15 through 46. All the things you're just asking questions about. That would be an example. Did we need to use our calculator at any point when we did those? No, everything got looked up off the unit circle, right? And then simplify a given trig expression. So again, what's that? You know, like 7 through 14 are worksheet 1 problems. Again, no reason you need to do it or need a calculator for any of those things. Okay. So there'll be 3 required questions. They'll come from that form. Some question from, or 3 from those 4 types. Then you'll have 8 proofs. You pick 5 to do. Why do I have it formatted that way? How many of us have looked at one and been like, I have no idea what to do with this? Right? That happens, right? And in a time test setting, that stinks, right? Because you can't just sit there and like, well, I'll look at it a little bit later. Let me think about this. Let me try some stuff. Like that can go bad real quick, right? That's why you're getting 8 and having to do 5. So if you see you're just something, I don't know what the heck to do with this, then don't do it. You can skip it, right? So the proofs will not be listed in order of difficulty. They don't go easy to hard. They're just kind of like randomly thrown in there. So the hardest one might be the first one, might be in the middle. Who knows? Maybe it's a matter of perspective, right? What's hard to one person was maybe easy for another. Most of them require just 2 to 4 steps if you're doing it like the most efficient manner. Does that mean if you took 7 steps to do one of these that you did it wrong? No, just might not mean, it means that you may didn't take the quickest route to get there. And again, some of them might be more work than 4 steps. That's okay. All the identity questions are the same points. So you don't need to like worry about that. They're all valued the same, so just pick the 5 that look easiest. I'm going to grade the first 5 that I see, even if it's blank. So the procedure for skipping one is that you put a big X on it, or you write skip on it. So when I say a big X, I don't mean like a little tiny X on the number. I mean like, make a big X. Don't be shy. Waste that pencil lead. Okay? Make sure, give Mr. Kulik no doubt that you don't want him to look at whatever you did there, even if it's blank. Again, if you try the problem and you decide, yeah, this went bad, this is not going well, I don't want you to look at this, don't have to erase it. Just put a big X, and I'll skip it. Any extra questions you solve will not be graded. So it's not like I'm going to grade all 7 and take your best, or grade 7 of them and be like, oh, your best 5 out of the 7 was? Nope. I'm grading the first 5 that you've done, that you haven't crossed out. Okay? And then, blah, 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 blah. Okay. So that's the test format. Does that seem reasonable format?
Yes.
Yeah, I like the idea of having some choice there on the proof ones where it's like, sometimes you look at it and you're just like, I don't know what to do with that. So you have a little bit of flexibility there. You got to know what to do with some of them, but not all of them, which is, I think, pretty fair. So this review was set up that we're to do this like collectively as teams. Do you want to do that, or you just want to work on stuff on your own?
Collectively.
I just want to do it on my own. I'm already almost done with it. So.
Tell you what, if you want to work with other people, feel free, work with other people. Talk it out, work as a team. If you want to just work by yourself, just work by yourself. I think that's best, right? If you have questions for me, feel free to come up and bother me. I have no problem with that. Okay? Don't be shy. If you're stuck, if you're not sure what to do, if you're just don't have a lot of confidence and you just need to talk it out, like, that's fine. Everybody cool? Okay. Sunday's problem set. Worksheet 1 in the chapter review, just as a update. We talked about this before break, but that was 10 days ago. Like, who knows? Okay.